Can I start? Hi all. I'm about to present Quicksort. What is it? Quicksort is a sorting algorithm, and I'm going to show you how it works. How I said to say how it works. The Quicksort algorithm search for a pivot that is a random number then he will pick the pivot and compare to the array. When he finds a higher element, he swap the position and swap the position with the index. The next step is to change the pivot to another element and to do the same thing until we have a sorted array. We know when we have a sorted array when all the numbers were previously pivot. They have to be all the numbers. So this here is an example. They show they shows the last one as a pivot, and then it will compare to the other numbers in the array and swap, as you can see. So this is the code in C from Quicksort. These three have that is a partition that creates the two different partitions of the array that divides in two parts and makes the pivot compare to the other, and the other one is a recursion to make it a circle. So now the complexity of the Quicksort array is this. The worst case scenario is when you pick the pivot. The first pivot is the highest value. So you will have to do more comparisons, so it will take more time. As you can see that it will be in verse 2. And in the base case, an average time is, and it's much quicker. This is complexity. So any more questions? It was quick. If you have questions. No?
So, hi everyone. I will present the Mergesort today. And Mergesort, what it is. Mergesort consists in the divide and conquer technique. That means that it doesn't solve the main problem as a one. First, it divides the problem in sub-problems, and then after finding a solution to the smaller problems, it combines the solutions in the bigger one. So, Mergesort, what it does is, imagine we have an array with 8 elements, and it's unsorted. So we need to sort the array. What we do is we divide the array into 2 halves, and then we divide each of a half in 2 halves again, and we do this recursively until we have lists of 1 element each. And then after that, we will compare each list of 1 element with the other next to him, and if it's lower, it goes first, and then it goes the bigger one. And we do this, and do this with all the numbers to get pairs, and then to get the 2 pairs with another 4 elements list, and do this recursively until you have the final solution. We have an example here with 8 elements and an unsorted list. So what we'll do first is divide the list in 2 halves, and then each of the half in 2 more, and finally we get the list with a single element. So now what we're going to do is compare, we'll compare the 4 with the 86, and we will see that the 4 is less, so the 4 will go here, and the 86 will go here. And we'll do the same with the other numbers, and we get this. Then we will do the same with the 2 lists. We'll compare the first element of this list with the first of this list, and the 4 is the smaller one, so it goes first. And then this increments, and we'll compare the first of here with the second of this list, and that is smaller go first, and we do that to all the lists, as you can see. And then we do the same, and we get the final solution. And as you can see in the last comparison, we have 286. So what's going to happen is that the 86 of the first half will go first, because the Mergesort is considered to be a stable sort, because it doesn't change the original position of the elements if you have the same value. And this is important in some cases when we need to maintain the same position with the same values. Here we have a part of the code is too big, so it has in the 2 slides. Here we have the recursion, where we divide the original list in halves recursively, and then we have the merge code, where here we compare 1 half with another, the first element with the first element of the second list, and if you compare, if it's the number that's smaller goes first, and then we increment. Here is the other option, when the element of the second list is the smaller. And in that code, what we do is see if 1 half of the array is reached the end. So if 1 half is empty, we will fill the array with the numbers left in the other half. So the complexity of the Mergesort is it will be always log n log n, because in the worst case and in the best case, because the Mergesort is a sort where we need to divide the original array. So an array with the n size, we can divide it log n, log 2 n times. So if we have log n levels and we do the work of complexity n in each level, we will get a final complexity of n log n. So it's the same as the Quicksort in the average scenario, because Quicksort in the worst scenario is n square, I think. But Quicksort usually is better, because Mergesort is more expensive in terms of memory, because it needs to allocate memory in heap or on another storage space to copy the original array, and then to proceed with the merge sorting. Finally, I will show you a video where it compares merge sort with Quicksort, and we'll see that in the first case, the Quicksort wins because it chooses the right pivot, because he almost divides the array in the halves. That's the best scenario. So Mergesort is doing the pairs, is comparing each element, and now we have a first half of the array, and he's doing the second half. And now the final solution, combining the two halves. As you can see, they made the same comparisons, Quicksort and Mergesort, but Mergesort was quicker. Quicksort was quicker because Mergesort spend I think you can't listen, but it has sound. It spends about 7 seconds moving the balls shelf to shelf, and it simulates the time that we spend with the memory access and that things. So we can see that Quicksort win partial to luck because it chooses the right pivot, because otherwise if you choose a wrong pivot it will take longer. But he divides the array almost in the halves because he chose a medium color, so it was a good scenario. Then we'll see the second case where the Quicksort choose almost the worst scenario, because as you can see, Quicksort choose the second lighter ball, so we need to compare with each one, and only the white ball is lighter, so he finds two positions, and then he picks the black, that it's the darker one, and he needs to compare with each one ball to see who is darker than the black, and there's no one darker than black, so it is wasting comparisons. As you can see, he has 20 comparisons, and Mergesort did only 18. So Mergesort already completed, and Quicksort is trying to sort because it chose the wrong pivot on the first time. So that's it. If someone has some question, I will try to do my best responding.
I do have one question.
Yeah.
What happens if the array is actually an uneven number?
An uneven?
It's 9.
Yeah. Actually, the example that I show, originally it was an array with 9 elements, and it divides the same, and then it combines. In this video, it's not an even number. So what it does is he combines he compares the 2 elements, and then it goes to the one that's the third one, and it compares with the first one of the list that is already sorted, and it does the same, and you have a 3 elements list that is sorted, and we do that until we have in this video it showed that. Yeah. So that's it.